Hi, welcome to the 10th module, which is on real-time data warehousing. So in this module, we are basically going to look at the need for data warehousing, um, the kind of challenges it throws, the solutions for real-time data warehousing. Then we are also going to talk about real-time ETL as a solution for real-time data warehousing, and the kind of impact it can have on real-time data warehousing. And finally, we are going to look at ODS, that is operational data stored, and we will try to see what role it can play in real-time data warehousing. So these are the topics. So what I've done is I've combined two lectures into one presentation. One is the first one was the need for data warehousing, real-time data warehousing, and the solutions. So I basically combined them into one presentation. So let us begin. So topics that are there are like, what is real-time data warehousing, why we need real-time data warehousing, challenges and solutions. So let us begin by looking at by trying to see some aspects or some emerging needs in this area, so that we understand that why we need a real-time data warehousing. So traditionally, data warehouses do not contain today's data. So basically, when I say today's data, that basically means that it does not contain the current data. So they are usually loaded with the data from operational systems at most weekly, or in some cases nightly, but as in any case a window on the past, but are in any case a window to the past, window on the past, right? So basically they are known for containing historical data and not the current data. So the fast pace of businesses today is quickly making these historical systems less valuable to the issue facing managers and government officials in the real world. So I'll give you some kind of situations which would help you in understanding this particular statement. So some examples. So morning sales on the East Coast, so this is about the US, will affect how stores are stocked on the West Coast. So basically, so there is a time lag between the East Coast and the West Coast, and based on the sales that are happening in the East Coast, right, I may take a decision to stock the West Coast accordingly. Airlines and government agencies need to be able to analyze the most current information when trying to detect suspicious groups of passengers or potentially illegal activity. So this is again real time. And fast-paced changes in the financial markets may make the personalized suggestions on a stockbroker's website obsolete by the time they are viewed, right? So all these are examples which tell you about kind of urgency, which could be an urgency of a few hours to almost zero latency, right? So these are some situations which we need to address, and these are situations in which we need a real-time data warehousing solutions. So as today's decisions in the business world become more and more real-time, the systems that support those decisions need to keep up. So it is natural way that a data warehouse system quickly begin to incorporate real-time data. DWBI applications are designed to answer exactly the types of questions that user would like to pose against real-time data, and they are able to analyze vast quantities of data over time to determine what is the best offer to make to a customer, or to identify a potentially fraudulent, illegal or suspicious activity. So there is a need. So all these tell us that there is a need for being able to do analysis in real time. Ad hoc reporting is made easy during using today's advanced OLAP tools. So all that needs to be done is to make these existing systems and applications work off real-time data. So So that is the main thing. So we nowadays have very good analytical tools, reporting tools, which give you answers very quickly, but at the same time we need to make them work for real-time data. So let us examine the challenges of adding real-time data to these systems and look at solutions for real-time data warehousing. So the main part is that most users would want to do some kind of real-time analysis, right, using the warehouse. And so we need to see, depending upon the urgency, right, we need to see what kind of solutions we can propose. So today's integration project teams face the daunting challenge that while data volumes are exponentially growing, the need for timely and accurate business intelligence is also increasing. So it's a double whammy, or a two-edged kind of sword, right, where your data is increasing, at the same time the the timeliness of the applications is also increasing, right? So we want everything in very quick time. So batches for DW loads used to be scheduled daily to weekly. Today's demand information that is as fresh as possible, and the value of this real-time business data decreases as it gets I'm sorry, there is some typo here. So the value of this real-time business data decreases as it gets older. So business, this should be gone from here. So just please strike off this. Yeah. And latency of data integration is essentially for the business value of the data warehouse. At the same time, the concept of business hours is vanishing for a global enterprise, as data warehouses are in use 24 hours a day and 365 days a year. So basically there is no downtime for the data warehouse, where you can stop the data warehouse and bring in fresh data into the data warehouse, right? And in the previous point you can see that there are these 2 points, right? So latency is essential, because unless there is latency, you would not be able to create or enrich the data that is going into the data warehouse, right? So that is also required. So with these two contrasting requirements, the real-time data warehousing becomes really challenging. So this means that traditional nightly batch windows are becoming harder to accommodate, and interrupting or slowing down resources is not acceptable at any time during the day. So from the previous slide, these are the kind of things that we can see. And also, integration projects have to be completed in shorter release time frames, while fully meeting functional performance and quality specifications on time, and should be within the budget. So basically we are saying that you fulfill some real-time requirements without asking for money or for extra time. So this is something that is becoming common in most organizations these days. And real-time data warehousing requires a solid approach to data integration, and most importantly, the ability to transform and filter data on the fly to ensure it meets needs of its different users. So BI applications and their underlying data warehouses have been used primarily as strategic decision-making tools that we know for a long time now, and they are kept separate from operational systems that manage the day-to-day operations. So significant industry momentum towards using DWBI for driving tactical day-to-day business decisions and operations. So that has changed the landscape, the data warehousing landscape, and everybody is trying to move towards the real-time data warehousing solutions. So basically you can see that data warehouses were initially proposed to for strategic long-term decision making, right? But now we are saying that we want to use them for tactical day-to-day business decisions, and I would say day-to-day or hour-to-hour or minute-to-minute decisions. All these things are to be included in the data warehousing system that you have. So active decision support. So these decisions could be strategic or they could be operational, so it doesn't matter. Business activity monitoring. So this is another activity where you want to monitor the health of the business or any activity that is going on. So business activity monitoring is another very important, which has to be done in real time. And then we have alerting. So this again, it is a kind of so if you know about dashboards, so this is like some kind of alerts are generated on the user screens, and which may represent any kind of a situation which needs immediate intervention. And positions information for use by downstream applications. So if we use real-time data warehousing, so it'll be able to quickly put info or position information for use by applications that are there downstream, right? That is after the data warehousing. So these are some situations which require real-time solutions, and users need to access two different systems, like in order to incorporate the real-time data. So data warehouses for a historical picture of what happened in the past, and many OLTP systems for what is happening today. Okay, so that creates problem, because OLTP systems, there will be numerous OLTP systems. So this is not a very happy kind of a situation for anybody to be in. So what I'm going to do now is I'm going to kind of contrast between traditional data warehouse versus real-time data warehouse. So traditional data warehouse, so we call them enterprise data warehouse or simply data warehouse. They are strategic, passive and historical trends, batch, so basically offline analysis, isolated, that is not interactive, and best effort, so guarantees neither availability nor performance. So whereas the real-time data warehousing is tactical, it focuses on execution of strategy, real-time, information on demand, and most up-to-date view of the business. So basically you can monitor the health of the business using real-time data warehousing. It is integrates data warehousing with business processes, and guarantees both availability and performance. So this is how you can compare and contrast real-time with traditional data warehouses. So real-time integration is what is required. So goal of real-time extraction, transformation and loading, so is to keep the data warehouse refreshed, and there should be minimum delay, as minimum delay as possible. And issues would be, how does the system identify what data has been added or changed since the last extract, and performance impact of extracts on the source system. So basically if you want to do real-time ETL, or if you want to bring in data as quickly as they are changed or as they are generated in the operational system, so it is not possible for you to bring all the data, right? So some kind of tagging has to be done that this data has changed, and basically we try to extract only that data from the warehouse or from the operational systems. And lineage, if you look at real-time data warehouse lineage, so operational data stores were which were called as generation 1 data warehouses, were kind of doing this real-time data warehousing. So I'll talk more about these ODS in the following lectures. And motivations for the original ODS were similar to the modern real-time data warehousing. And implementation of real-time data warehousing reflects a new generation of software and hardware techniques which we can use to provide these solutions. So the main idea is that ODS which were proposed long back, so they are basically four classes of ODS, and class 1 was so class 1 ODS is as close to data warehouse as real-time data warehouse as possible. So implementation of real-time data warehouse reflects a generation of software, hardware, and techniques. So we'll look at these techniques as we look upon the solutions for real-time data warehousing. So one of the solutions which was proposed by Kimball, and I have a reference towards the end of this about this particular technique of real-time fact table partitions. So it is about how do you model the real-time, how do you model the fact tables in a real-time environment. So assuming that an application requires a true real-time data warehouse, the simplest approach is to continuously feed the data warehouse with new data from the source system. But these has issues, and downtime and scalability issues are there with this. So this can be done either directly inserting or updating data in the data warehouse fact tables, or by inserting data into a separate fact table in a real-time partition. So this basically takes care of the problems that I just mentioned, that the downtime. So while the fact table, so if we keep it in the same, or if we put the data in the same fact table that we have in the data warehouse, so there may be some kind of downtime. But if we put it in a separate fact table, and which we call as the real-time partition of the fact table, then this particular problem is not there. So real-time partitions, these are called as generation 2 partitions. Separate real-time fact table is created whose grain and dimensionality matches that of the corresponding fact table in the static, nightly loaded or weekly loaded data warehouse. And real-time fact table contains only current day's facts and only those that are not loaded in the static fact table yet. Each night, the contents of the real-time fact table are written to the static fact table, and the real-time fact table is purged, ready to receive the next day's fact. So, and this activity, this last activity, can be combined with the conventional or the nightly ETL process. So you understand this. So basically what, so let us try to understand this. So you have a fact table which we call as the static fact table. So what we do is that through ETL, one way is that I keep on putting data as and when it is generated into this fact table. Instead of this, we are saying that this ETL would put a data in a real-time fact table. So instead of going here, this data directly goes here. And every night, I put the data back in the original fact table. And any real-time query or query which requires real-time works on the real-time fact table only, right? And this is done every day, right? So throughout the day, the data is fed into this. The current data is fed into the real-time fact table partition, and then in the night it is put back in the, or it is put in the original fact table, or the static fact table as we call it. So what kind of benefits it gives is that it gives real-time reporting benefits of the ODS into the data warehouse itself, eliminating the architectural overhead the ODS architectural overhead. So you will see that we'll discuss this ODS part in the one of the following lectures. So it eliminates the need of the architectural overhead caused by the OTS, and facts are trickle fed into the real-time fact table partitions throughout the day, and user queries against the real-time fact tables are neither halted nor interrupted by this loading process. Right. So data is not fed periodically, it is trickle fed. That is, as and when the data is generated, you keep on putting this data into the real-time partition. And some other aspects of this is that indexing is minimal, so we don't index it too much, right? And performance is achieved by restricting the amount of data in the real-time fact tables. So we don't like, since it contains only the day, single day's data, so the size is controlled, or the amount of data is controlled, and it is most of the time it is possible to cache the entire real-time fact table in memory, so that there is no need for I/O, which is expensive. So the queries can be answered in very, very quick time. So basically this gives you two benefits as such. So first thing is that it is very small in size, right? And suppose this is my memory, right? It is very small, so this is a real-time fact table partition. So it is very small in size, and so the queries anyway would run faster. And the second thing I do is I park it in the memory, so that I cut down on the I/O costs also. So this helps in answering queries on the real-time data very, very quickly. And create view to combine data from both static and real-time fact table, providing a virtual star schema to simplify queries that demand views of historical measures that extend to the moment. So if you also need a query, if you also have a query which is trying to look at the real-time data as well as the fact data, so we can create a view, right, which will be a virtual view. Views are virtual anyway. So create a view, and queries could directly target this view rather than targeting these fact tables, two types of fact tables. So this view can give you that illusion that real-time data is actually in the fact table, in the static fact table. So fact records are trickled trickle fed into the RTDW issues. So let us see what about the changes to dimension tables that occur between the nightly bulk loads. So because we are not touching only we are not touching the dimension tables, or we are not talking about the dimension tables. Say what happens if new customers are created during the day, or new customers join during the day. So does this approach tell us that are we focusing only on fresh facts and not on fresh dimensions as we should, right? So let us see what is done for this. So real-time partitions, so hybrid approach to SCD in real-time environment. So we are saying that it is not that we are not focusing on the dimensions. So what we do is, so the intra-day changes to the dimension tables are treated as type 1 changes. So all of you, we have discussed this type 1 change, where a special copy of dimension table is associated with the real-time partition, and changes during the day, during the trigger simple overwrites. This should be during the day trigger simple overwrites, and at the end of the day any such changes can be treated as type 2 in the original dimension table. So during the day it is type 1, right, and this type 1 changed or type 1 handled dimension is associated with the real-time partition, real-time fact table partition, right? And during the day or during the night, when we push all the data from the real-time fact table partition into the static fact table, we also apply type 2 changes to the dimension tables, right? So this is how it is handled. So it is not that we just focus on the fresh facts, we also incorporate fresh dimensions using type 1 changes. And these are the references that I have used for this. So there's a nice article by Langseth, so I've given the reference, and I've also used material from an Oracle white paper which was published last year, and also this real-time partitions article from in Intelligent Enterprise from by Ralph Kimball, right? So these are the references that I've used. So I hope that you have understood the need for real-time data warehousing and the kind of challenges it poses, okay, and how this simple solution to have a separate real-time fact table partition helps, and also this concept of type 1 changes being incorporated through the day on the dimension tables, so that also helps in having fresh dimension records also in the star schema. So in the next lecture I'm going to talk about ETL and real-time ETL. So that also is another kind of solution that is proposed for real-time data warehousing. So with this I end today's lecture, and in the next lecture I am going to talk about real-time ETL and the role of ODS in real-time data warehousing. So with this I wind up today's lecture. Thank you.